Hi, my name's Howard Levinson. I'm the General Manager for Databricks Federal, and I'm excited to share with you our approach to modernizing government analytics with a lakehouse architecture. Let me tell you a little bit about Databricks in case you're not familiar. Our founders are the ones that originally created Apache Spark, and we've created a whole bunch of other open source frameworks, including Delta and MLflow, that we'll talk about during the discussion today. We've got over 5,000 customers, and we are the creators of this new innovative approach towards building data lakes called Lakehouse. And we're going to talk a lot more detail about what a lakehouse is and what the benefits of it are. Before we do that, let's talk a little bit about the state of data and AI in the government. So, we know data is the new gold, the new oil, the new bacon, whatever you want to call it. We know that it's disrupting every industry on the planet, whether it's Airbnb disrupting the hotel industry or whether it's Uber disrupting the car rental industry. Data and AI are disrupting every industry. And there are some innovators in the Department of Defense and in the government in general that are really having an impact and doing amazing things with AI and ML. One of our great customers, the United States Air Force, in a program called Vault, is actually reducing the amount of downtime that aircrafts have based on the analytics that come out of the aircraft engines. It may not be clear to everybody, but a single engine will generate a terabyte of data every hour in sensor data. And that sensor data can be analyzed to determine predictive failures and to improve the efficiency of that engine. Guys like US Citizenship and Immigration Services, they are using big data and analytics to synthesize many different data sources or federate all of these different data sources together. And today they've built an implementation that allows them to approve visas and naturalization paperwork faster and give their community of users a better insight into the way people are coming through the system, ultimately providing better service to citizens and visitors to the country. The DC water supply is actually processing hundreds of thousands of meter reads per hour. And what they're able to determine based on, analytics is whether there's been a water main break before the water main actually breaks. Because typically there are small leaks that take place. And when they see these in the sensor data, they can take proactive action, saving literally hundreds of millions of dollars in damage and costly repairs. And finally, the Center for Medicaid and Medicare Services, well, we all know there are hundreds of thousands of claims, millions of claims. Medicaid is delivered by the states and territories, and all of that data comes back into CMS. It's got to be synthesized, it's got to be normalized, and it's got to be analyzed to figure out if we're providing the very best healthcare and whether there's fraudulent transactions in there. And all of these customers are using Databricks to accomplish the very tasks that I just shared with you. Now, data and AI is a top White House priority. So many of you guys are familiar with the fact that there's this IT Modernization Act. I think it came out a couple of years ago. And the idea here is to move from on-premise data centers into cloud-based environments. And I think that's pretty important relative to the fact that we're talking about AWS Public Sector Summit here. But there's also other initiatives. There's this federal data strategy where they're asking every chief data officer, well, first of all, they're delivering chief data officers to the government. And the first task for these chief data officers is to catalog, democratize, and provide governance of the data. So we're really treating data as a strategic asset. And then finally, there's this AI executive order. And the AI executive order is really to drive artificial intelligence through new funding into everything that the government does. It's not just the federal government that's doing this. All of the states are doing it too. You can look at some of the things on the slide here, but you're seeing that algorithmic officers are being defined, and AI is getting started in just about all of the state and local governments as well. And it's not just legislation. There's a lot of money going towards this. The federal government's going to invest $1 billion in 2021 in artificial intelligence and in machine learning. Gartner studied the top priorities for many of the government CIOs. AI and ML, data analytics, and cloud are the top three. And Deloitte looked at the amount of productivity gains that could be achieved by implementing AI and ML. This is on an annual basis, $41 billion. It's just an inordinate amount of money that can be saved if we do this properly. But there are challenges as well. In the federal government and in the public sector in general, the skills aren't there. This was a study done by Deloitte, and it recognized that there was a skills gap in getting public sector employees over this skill gap. And Databricks says, our founders were all academics. They all came from UC Berkeley and their PhDs. And so, training people is a key part of what we deliver. There's also other challenges. We mentioned the IT Modernization Act and the idea that we want to move everything to the cloud. But when you think about the federal government, the OMB did this study a couple of years ago. There were 12,000 data centers across the federal government. 12,000 data centers, each one of those data centers having a broad set of different data repositories. You can think of tens of thousands of islands of data that exist within the federal government. And in order to do AI, we know that you've got to bring all of that data together. The cloud's a perfect place to do that. Then you've got to normalize it so that my schema is consistent. And only then can you start to apply artificial intelligence and machine learning to the data. And so these are some of the challenges that Databricks is here to help our public sector clients solve. So before we go into the solution, let's talk about maybe the evolution of data management and a little bit about the history so we can figure out where we are and how we move forward. So for decades, people have successfully used data warehouses. These things are great environments for dealing with structured data, basically tabular data. You can put all of your tabular data into a data warehouse, and then you can use business intelligence tools that many of you are familiar with, like Tableau or Power BI or Qlik or Cognos, and then you can run queries against that data. The problem with these data warehouses were they were proprietary, which made them expensive. They were really expensive to scale because you had to buy all these proprietary components. They only supported SQL. You couldn't bring any advanced programming languages like Python or Java to these data warehouses. And as a result of the fact that you couldn't bring these advanced programming languages, you really couldn't do machine learning and artificial intelligence. And by the way, they only handled structured data. So that was really great 20, 30 years ago. But today we know that the data's coming in, it's full text, it's imagery, it's voice, and you've got to be able to analyze all of those capabilities, and data warehouses just didn't do it very well. So along comes this great idea called a data lake. And these data lakes are really places where you store all your data, you bring it all together. You could do artificial intelligence and machine learning now because you had all of the data in one place. These were fairly economical because they used low-cost storage, but they really couldn't do the things that the data warehouses did. In other words, it was hard to bring your BI tools to these and just run standard queries. And these data lakes very frequently turned into data swamps. There was a lot of data in them. The data wasn't normalized, it wasn't structured, and it was hard to make sense out of it. And like I said, people referred to these things as data swamps. So people came up with a hybrid solution. They said, hey, let's first put the data in the data lake, and then we'll go through this process called ETL, extract, transform, and load, that we've been using for decades, and we'll build a data warehouse in the cloud. And you'll see that there are a lot of people that are doing this, like Teradata and Snowflake and many others. The problem with this approach is now I still have 2 copies of my data. I've got 1 copy in the data lake, 1 in the data warehouse. I've got 2 versions of the data potentially, if I updated one of those, 2 different governance models here. And this stuff is just costly to maintain because now I've got to have 2 teams supporting both of these approaches. So let's look at what this looks like for most organizations today. And it's not just that people had data warehouses, people had like entire solutions for doing that data engineering, doing data transformations, data normalization, extract, transform, and load. There are really big tool sets that people delivered to pull the data out of their operational data stores and load them into the data warehouse. More and more often, people are not only dealing with batch data that was synonymous with ETL, but we're dealing with streaming data, whether it's IoT data or even that USCIS example that I shared with you, which was really structured data, but now they're getting that data in a streaming fashion and they want to load it into that data warehouse instantaneously. And they'd end up with a separate vertical with a separate set of clusters and real-time databases for doing that streaming stuff. And then finally, there'd be yet another vertical for doing data science and machine learning, where they typically export the data into a program like SAS to do all of this advanced analytics. And as you can imagine, there were separate stacks to do all of this stuff. So a lot of complexity and technical debt. The data had to move sideways and up and down. And so a lot of data movement, which was fragile and expensive to move. But almost as importantly, there were walls and barriers built between the personas that did this data. So you were either had the role of a data analyst, a data engineer, or a data scientist, and they typically didn't talk to one another. Now, you've probably heard that data scientists spend 80% of their time doing data engineering. Why is that? Well, it's because the data engineers aren't actually collaborating with the data scientists, and they're not actually delivering the data in the format and the schema that the data scientists really want. And that's as a result of these stovepipes that have been built over the years. So I'd like to introduce you to this new concept called Lakehouse. And the really cool thing about Lakehouse is it takes really the best things about the data warehouse, really good at structured data, really good at business intelligence, and the really good things about the data lake, which is really inexpensive storage and the ability to store structured, semi-structured, and unstructured data and be able to apply artificial intelligence and machine learning to that. One of the innovations that Databricks delivers that makes the Lakehouse a reality is this capability we call Delta Lake. Now, Delta Lake is a new file format that's built off of the open source Apache Parquet format. And what we deliver with Apache Parquet is the ability to transactionalize those files and those workflows. So these capabilities that we've had in databases for decades, which was called ACID transactions, where when I wrote something to the database, I either wrote it completely or I backed it out. Well, Delta delivers that in the data lake. And so for the first time now, you can get reliable transactional writes and reads from object stores like Amazon S3. And we can deliver this because the Delta Lake adds this journal. It adds the ability to provide indexes and all kinds of go fast features in addition to these high availability features like schema, enforcement, and ACID transactions. So you really get the best of both worlds with Delta Lake. Now, Databricks delivers this capability right in the AWS environment, and it starts with the ability to deliver structured, semi-structured, unstructured, and streaming data all in Amazon S3. It's completely open because we've open sourced Delta Lake. It's downloaded by millions of people, and it's today, I think we process in the range of 2.5 exabytes a month in Delta Lake. So it's really become a de facto standard. And Delta Lake, on top of the ability to provide high quality and high performance data, it offers a level of governance for your data in S3. So now that you can determine who has access to the data and what access they have. The really powerful part of this lakehouse architecture is now I have one single source of truth for my data. It's all sitting in Amazon S3, which is really inexpensive and really durable. And from that single point of truth, I have one framework where my data engineers, my BI and SQL analysts, my real-time applications, and my data scientists can all work together. And that's really a fundamental part of what Databricks delivers, is this simple, open, and collaborative environment for all kinds of data and data analytics. So when I say simple, I mean simple because it really unifies everything together. It's a single source of truth for your data. And again, it's a fully managed service on the Amazon ecosystem. I really believe in the concept of open software. And it's really part of the reasons I came to Databricks was because Databricks, like our founder says, we want to lock people in with great value, not with proprietary features. And so our whole thought process is people can develop better software and more secure software through openness. So I mentioned our founders created the open source project called Apache Spark. But since then, Databricks has continually innovated, and most of these innovations are brought to open source. We offer Delta Lake as an open source file format. We offer a capability called ML Flow, which is a lifecycle management framework for machine learning frameworks, for machine learning codes and models. We offer a solution called Koalas, which allows you to take software written in the popular Python Pandas API and automatically parallelize that for Spark. And we also offer a business intelligence interface or a SQL interface to the entire Databricks framework through an open source investment that we have called Redash. And as you can see, these are not just open source, they're incredibly popular programs that are all brought together by Databricks in a synergistic way. And it's really because of this openness that Databricks has this incredible ecosystem, because nobody has to do anything special to interface with Databricks. We can support, all of the data integration tools that many of our customers are familiar with and have been using for decades. All of the business intelligence tools that I described earlier just plug right into our Lakehouse architecture. Many of the popular machine learning framework, including Amazon SageMaker, are direct fits, and our model capability in ML Flow allows us to flow those models directly into SageMaker for evaluation. And even the centralized governance capabilities can be done with popular platforms like Immuta or Privacera or even AWS Glue. So openness is a really powerful part of the solution that we deliver. Collaboration is another really important part of the overall solution. Remember, I described earlier that data scientists spend 80% of their time actually doing data engineering. They're doing feature engineering, and they're really modifying and transforming the data sets so that they can actually start to do their machine learning. But if we can get the data engineering teams to put the data in the format from the get-go, those data scientists can spend their time actually doing data science, building those machine learning models and those deep learning models. And data analysts are key to this as well, because right on top of the Lakehouse, with all of that data in S3, you now can run your SQL queries against it. You no longer have to build that hybrid architecture that we saw before and import that data into a data warehouse. Now your SQL analysts can run directly against all of the data that you have in S3, not just the subset that you've curated into that data warehouse. And remember, because there's no data warehouse now, there's no complexity with governance, version control, or even the costliness of having multiple copies of the data. So the next question you might have as a public sector client is, does Databricks meet the compliance requirements? And the answer is an emphatic yes. In fact, it doesn't really matter what your compliance requirements are. Databricks runs in just about every environment that you can imagine in the federal government, including highly classified networks like JWICs to DoD networks that are IL5 and IL6 compliant, all the way down to civilian agency organizations requiring FedRAMP and FISMA compliance. And Databricks meets all of those requirements, and we can deliver, and we've got customers running in all of those environments that you can see on the slide here. So we're trusted by many in the commercial space, as well as in the federal government, as well as in state and local governments. As you can see, there's New York Power Authority and many other state and local governments that are major customers of Databricks. I was really excited that Sandy Carter shared the success that Databricks and AWS had together at U.S. Citizenship and Immigration Services. It's a major success story for the government as well as for Databricks. We're really proud of the work that we did here. This environment today is used by over 7,000 people every day. It allows USCIS to get better analytics and better insights into the data and into the people that are seeking visas and naturalization in their environment. Another thing I'll say about Databricks is almost all of our customers are seeing incredible benefits in terms of return on investment. For our commercial customers, they're seeing actually higher revenue just as a result of doing better analytics on their customer databases. And if you think about how we can deliver this to the federal government and provide better services to the constituents using some of those same capabilities, boy, the power is endless, including the fact that data scientists are in such short supply. If we can improve the productivity of those data scientists, wow, the future is limitless. So what I would say to you is, because we're a cloud service, it's really easy to bring Databricks in, test it on your data, and see if we can provide that same level of value for you in your agency or your public sector organization. So I would suggest to you, pick a use case. Let's sit down, let's talk about that use case and how we enable it. And the next thing you know, within a week or two, we'll have your data ingested into Databricks and showing you insights in that data that you didn't even know existed. So with that, I'd like to thank you. I'd love for you to reach out to me at howard.data@databricks.com. It's really simple. If you've got further questions, I'd love to continue the dialogue there. I'm also on LinkedIn if you'd like to find me there. And you can go to our webpage, databricks.com/government, and you'll find lots of other stories and use cases about Databricks. So with that, I thank you, and I look forward to the additional conversation in the future.